So in this situation, we have a 9.2 kg case slid across the floor by applying a force of 21 newtons west. We know the case experiences an acceleration of 0.32 meters per second squared, and I want to know the coefficient of kinetic friction. This is essentially reverse engineering what we've did in the last example. We know that we can find the net force on this crate, on this case, by using F equals ma. We know the mass of 9.2 kgs. We know the acceleration it experiences of 0.32 meters per second squared. And we can find the net force. Why is the net force important? Because with any kind of motion, some of the applied force of 21 newtons will go into moving the object, and some of that will go into overcoming friction. Once we know the net force, then we can determine how much goes where. So knowing that F net equals ma, substituting in mass 9.2 kgs, acceleration 0.32 meters per second squared, multiplying that out to 2 sig figs gives us 2.9 newtons of net force, which means 2.9 newtons goes into moving the case, and the rest of the 21 newtons goes into overcoming friction. So to find the force of friction, we can take the applied force, subtract off the net force. So 21 newtons minus 2.9 newtons would give us 18.1 newtons worth of frictional force. Now that we know this, we can deal with the equations for friction. I'm going to use Fk now instead of FFR, just because we know specifically this case is moving, so it'll be kinetic friction equals mu s times the normal force. We're being asked to find the coefficient of kinetic friction, that is mu s. Fk we just found, 18.1 newtons, but the normal force we don't know yet. And again, the normal force is equal and opposite to the force of gravity, and we can determine that quite easily. Mass of the case, 9.2 kgs. Acceleration due to gravity, 9.8 meters per second squared. And so the normal force going to 2 sig figs would be 90 newtons. Substituting that and the force of kinetic friction in, we get 18.1 equals mu s times 90. Dividing this out, and again 2 sig figs, we get the coefficient of friction as 0.20.